Good morning. We are here today to learn chemistry, form 2 work, topic structure and bonding. Just to start with, we would start with the definition of what the structure is and what the bond is. Structure and bonding. Structure and bonding. So we will define the two terms. The first one we want to define is a bond. A bond. In real sense, we always say a chemical bond. Now, what is a chemical bond? A chemical bond is a force of attraction, a force of attraction between atoms, or molecules, So we are saying a chemical bond is a force of attraction between atoms or molecules. Now, the second term we are supposed to define is the term structure. And to define the term structure again here, we would talk about the structure being a regular pattern, of arrangement, of atoms or molecules. That is showing how they are linked. They are linked to one another. So I'll go back there and recap that again, and we are saying the topic is structured bonding. There are two terms here from the topic. One is structure, the other one is bonding. So we're starting with the word bond, or in other words, chemical bond. So what is a chemical bond? We are saying that a chemical bond is defined as a force of attraction between atoms or molecules. And again, we are saying here that structure is actually the regular, I think there's a mistake there. Can put that down. Well, regular pattern of arrangement of atoms or molecules, showing how they are linked. They are linked to one another. Let me correct that. They are linked to one another. How they are linked to one another. Now that we know that there is a structure and there is also a bond, I want us to just have a table here to briefly show us the outline of what we're supposed to discuss. And this outline would have the chemical bond on this other side, and then the arrangement where it is found, and that is now the structure that you would find such a bond. The structure that you'll find such a bond. So the first bond we want to put down, which we will discuss as we go on, the first bond we have is an ionic bond. Ionic bond. Ionic bond. Now, ionic bond is found in a structure which is also known as giant ionic structure. Giant ionic structure. Giant ionic structure. Giant ionic structure. Let me make this big so that you can see. It looks like my ink is fading when exposed to air. So we're seeing giant ionic structure. So in giant ionic structure, we always find ionic bond. So where we have ionic bond is where we have the ionic structure. So if you have any compound that has a structure known as giant ionic, then the bonds inside are just but what? Ionic bond. The second category of a bond which you're supposed to talk about, second category of a bond that you're supposed to talk about is covalent. Covalent bond. Covalent bond. And for covalent bond is found in structures that I will name here. There will be actually two structures. The first structure is giant atomic structure. Giant atomic structure. Giant atomic structure. The second one is molecular structure. Molecular structure. Molecular structure. Molecular structure. Molecular structure. Now, the molecular structure, again, we will discover that this molecular structure is subdivided into two, and I'm just about to do it here. But in the molecular structure, we will find a structure known as simple molecular. Simple molecular. And we also have what we call giant molecular. Giant molecular. We will get to understand this as we continue. So far, there are two bonds, but the structures I've given are actually three. Now, for bond number three, and this is a special bond, and this bond is metallic bond. Now, for metallic bond, I'm seeing that going to collide with that. Just to correct that a bit, that space is not enough. We are seeing the third special bond, number three. It's unique on its own. This is number three. We are seeing metallic bond. Metallic bond is found in a structure which we will also discuss, that is structure number 4 here, and that is giant metallic structure. Giant metallic structure. So you will discover there is a pattern here. For ionic bond, the structure is almost similar to it. So it is ionic and a giant ionic structure. Here we are talking about giant metallic structure. So it's a metallic bond, giant metallic structure. Then there is another special bond which will not confine or will not talk about in terms of either a structure where it is or not. That is bond number 4. The type of bond number 4 is almost similar to covalent bond, but it is special again. We have what we call dative bond. Dative bond, it's a special one, and you can find it in several structures which have already been mentioned. So here I will put not applicable here, but in structures that you will find it, you may find it in ionic, you may find it in giant atomic structure or even molecular structure. We'll talk about that when we come to that level. Now, if I am to again summarize, remember when we were defining the bond, we said it is a force of attraction between atoms. I'm sorry about this, I didn't see this. It is between atoms or molecules. So the molecules, these molecules we talked about here, when they are joined or they are linked or they attract each other, there are bonds in between them, and those bonds have been given a name which I want to give here. Now, the bonds that link molecules are known as intermolecular forces. So we have other bonds, so I will say here other bonds, which we actually call intermolecular forces. Intermolecular, remember this is not now there. Intermolecular bonds stroke forces. Intermolecular bonds stroke forces. There are three of them here, but two are the main ones. The third one is a special one in one specific compound. So the first one we have is one commonly known to us, that is weak van der Waals forces. The Waals forces as intermolecular bonds. Then we have what we call hydrogen bonding, or just hydrogen bonds. Then we have one special one which I've already mentioned up there. In a compound, there is in a compound where it is serving as an intermolecular force, and that is dative bond. Dative, sometimes referred to as coordinate bond. Coordinate bond. Coordinate bond. Coordinate bond. Coordinate bond. Now, because of time today, I'll only introduce one of the bonds here. The first one we're discussing today is an ionic bond. Now, we want just to briefly talk about an ionic bond. I hope this will go. It appears not to be clear, but I hope it would be clear. This pen of mine is leaving a blue mark here. I just want to hope it will not leave the board colored such that you are not able to see. But I hope you will be able to see. Good. So the first one, maybe I use a different one from the one I'm using. So we're saying our first bond is ionic bond. Ionic bond. Ionic bond. Ionic bond. Ionic bond. So what is an ionic bond? Now, the word ionic suggests the kind of bond you're talking about here. Now, an ionic bond is, I would say here, is an electrostatic attraction. It is an electrostatic attraction, electrostatic static attraction electrostatic attraction between ions, mark that, ions of opposite charges, that result from complete transfer I'll underline that, complete transfer of electrons from one atom to another, So we are seeing an ionic bond, as the name suggests. We are saying it is actually an electrostatic attraction between ions of opposite charges that result from complete transfer of electrons from one atom to another. So when we say ions of opposite charges, we know the basic law of charges, where we say like charges repel and like charges attract. So that is why we are saying ions of opposite charges. Obviously, ions of opposite charges would attract. So the attraction between these two ions, the attraction is what we call what? The ionic bond. So the ionic bond is actually the attraction. So we are saying ionic bond constitutes, in other words, constitutes the electrostatic attraction, the electrostatic attraction. Between two ions of opposite charges. Wonderful. All of us know how ions are formed, and in most cases we say ions are either formed through loss of electrons and gain of electrons. So we are kind of saying that in this kind of bond, the ions are of different charges. That means one was either formed through loss of electrons, the other one was formed through gain of electrons. How does this occur? That is what we want us to discuss here very quickly because of time. How does this take place? Now, I want to use an example here to illustrate. And we are saying, in other words, we can say it is an attraction. It is an attraction between a cut ion and an anion. Attraction between two ions of opposite charges. So for ions and for charges, we only have two. We either have a positive charge or a negatively charged ion. So to be very clear here, let me use an example. For instance, formation of sodium chloride. Formation of sodium chloride. And the formation of sodium chloride, if we go keenly, let's start with the formula. So formula we have there for sodium chloride would have NaCl. Now NaCl in the real sense takes us to the attraction and the ions. So ions, the ions we have are sodium ion with a positive charge there, and the chloride ion with the negative charge. So it is these two that are attracting each other electrostatically, and we're saying that is the ionic bond. Just to illustrate further, look at this. This is what we are saying, that you have sodium there, it is an ion, and we have a chloride, which is also just but an ion with a negative charge. So this attraction, the attraction here is what we call ionic bond. Ionic bond. It is the attraction between these two. Attraction between the two makes it the ionic bond. Now, how does it come about? How do these ions come about? Now, from our knowledge of configuration, sodium 2, 8, 1. For chlorine, we know, and for chlorine, we know it is 2, 8, 7. Sodium needs to lose 1 to be stable. Chlorine needs to gain 1 to be stable. And we are saying for the periodic table we know about, we always say that group 8 elements are stable, but the rest of the elements only gain their stability through loss of electrons or gain of electrons. And in this topic we'll know there is also the third way, sharing of electrons. But here, what happens? So because sodium needs to lose 1 to be stable, loses that 1 electron, and this 1 electron being lost is gained, and so we are saying gains that 1 electron, and in that process ions of opposite charges, which I want to now take down here. And you don't kill me, I know the time is up, don't kill me for this. So in real sense what we would have is a bond there, we have our sodium ion, 2, 8, remember it has lost 1, 2 electrons, the innermost, then we have our other 8 of them after losing that 1. Allow me. So it has lost the 1, it becomes that, but this time round it's a special one. It's not just an atom. The configuration of writing that, we put a positive charge. Positive charge. I don't know if that is clear, but I can do that, I can make that clear. Forgive me for this. Yeah, this should be somewhere there so that we see this. So we're seeing loses 1 electron, and here we are now saying this acquires a positive charge. We are done with that. On this other side, chlorine on the other side now does what we call gains. And which electron is it gaining? 1 that sodium is losing on the other side. So gains 1 electron. And when chlorine gains now, things become so worse. It now becomes negatively charged, and we're seeing this is how it goes. Now, to show the difference between the electrons, I'll use dots on this side. So for chlorine, we have the innermost having 2 dots, correct? the second energy level having 8 electrons, so we'll put a dot there and a dot there, another dot there and a dot there, another one there, there, another one there and there. Good. Then the last one, which had 7, ended up gaining 1 from sodium. And so the first thing we would do is show, and the showing is dot, dot, another dot there and another dot there. Remember there were 7, so you look at this keenly, there were 7, so there is a dot there. But to show that chlorine has gained 1 electron, as we say there, we would use an X, showing that this electron wasn't here before, it came about. So we have a cross here showing that there is an electron that has been gained. And for that reason of gaining the electron, the chlorine atom turns into a chloride ion that has a charge of negative 1. Negatively charged, positively charged, opposite charges attract. So it is this attraction. And remember, when you're drawing this, you should not leave a very big space here. There should not be space at all, because it is an attraction. This attraction here is what we call ionic bond. And because of time, I don't think I'll go beyond that. But I would wish to say when it loses the 1, it becomes 2, 8. While when this one gains 1, it becomes 2, 8, 8. Unless we have a question, I would wish to summarize and come back again. And we're saying that an ionic bond is an electrostatic attraction between ions of opposite charges. How do these ions come about? They result from complete transfer of electrons from one atom to another. And in my example here, I'm saying there is sodium and there is chlorine. There is a reaction between them to form sodium chloride. So for sodium chloride to come about, sodium atom loses an electron, 1. In short, it transfers the electron from itself to chlorine atom. Then chlorine atom gains it, and that is why you're saying it is complete transfer of electrons. So this is complete transfer of electrons to who? To chlorine. I can bring this. So we are seeing the electron being lost goes to chlorine, loses to chlorine. So the chlorine gains the electron. When the chlorine gains the electron, it forms a negative charge. When sodium loses the electron, it forms a positive charge. So a positively charged ion versus a negatively charged ion attract, and it is that electrostatic attraction that we call an ionic bond. I would wish to stop my class there for today. We will continue next time showing more examples of ionic substances using the dot and cross diagrams. Thank you.